Hello, and welcome to the BinarX Student Payload Development Program Week 19, Preliminary Design Development. This week, we are going to further learn how to read a data sheet and find the information we need in order to interpret and process the data we're getting from our sensors. We're going to connect a temperature sensor to an Arduino micro on a breadboard, and we're going to program that Arduino micro to read the temperature sensor. Once we've done that, we're also going to learn to use the serial monitor function in Arduino IDE, that software you use to program the microcontrollers, to read the output from the sensor. So you'll need some of the components from your Introduction to Electronics kits, a breadboard, the Arduino microcontroller, the temperature sensor from last week, which is the MCP9701. It's in your boxes. Male to female jumper cables and male to male jumper cables or wires. You'll also need a micro USB cable to connect your computer's USB port to whatever type it is to the Arduino micro. So you might have that in your box, you might not, but just make sure you've got the cable that you can connect the microcontroller to whatever computer you're using. So that computer that you're using will need to have one available USB port and the Arduino IDE software installed, which you should have. If you don't, talk to your teachers about getting that installed. You can always come back to this another week. An internet connection and a printout or electronic copy of the MCP970X temperature sensor datasheet. Apologies, that's not the same datasheet from last week. That one was very similar, but for this week, you'll need the specific one for the temperature sensor in your kits to do the coding correctly. So some updates. Binar 2, 3, and 4 have been patiently awaiting deployment into orbit from the International Space Station after reaching the ISS on August 6, 2024. You remember after our launch and we reached the ISS, we've been sat there for the last couple of weeks waiting. And I'm really excited to say that we are going to be rescheduled to be deployed into orbit for 7:20 p.m. Perth time this Thursday, August 29th. With the live stream commencing at 7 p.m. So we don't have a link for it yet, but we should have one early in the week of the deployment. So teachers, please keep an eye out with an email with the link, and we'll also post it on our socials, including Instagram at Binar Space WA. And this time you don't have to go anywhere. You can watch from the comfort of your living room. So hopefully you'll tune in for that. All right, so let's get started. Again, apologies, the temperature sensor data sheet was a different one, so make sure you've got the one from this week. And we're going to use that familiar sensor, like the temperature sensor, to explore how an analog sensor reacts to its environment, and then using the data sheet, learn how to translate that data into the form we need. In this case, degrees Celsius. We won't do that equation in this session, but maybe next week, but we'll at least learn to print that out so that we can see what value our sensor is spitting out. So looking at the data sheet, this is the new data sheet, the MCP9701 data sheet that's in this week's resources. You've got the pin configuration, so take note of which package your sensor is. And if it's an integrated circuit, well, we won't worry about that on the other ones. But yes, if it's more similar to the TO92 or the like we have for this temperature sensor, take note of the shape of the component and match the pins accordingly. So you can see in this example, we have the packages and pin configuration on the left. That's from the data sheet on page 2. And on the right is an image from the Mouser Electronics website where we buy the components. And that's the TO92 package for the MCP9701, which is what you have in your kits. And then the one below that photo, you can see it's the same sensor, but it's in that SC70 package with 5 pins. So you can see how that translates over. So TO92, you've got your voltage, your supply voltage, your VDD, your V out, and your ground. So going over the specifications table that is in the new data sheet, we won't go right the way through it, but you've got your, same as last week, operating voltage and the accuracy. And you'll see, actually I've highlighted the one because you'll see all different model numbers on in the left-hand column, or sorry, the right-hand column there. So you've got MCP 9700A and 01A, you want to make sure you find the specific values for the one that you have, which in this case is the MCP 9701. And then on the right, we've got DC electrical characteristics, which you'll need for later. So the output voltage at 0 degrees, which is 400 millivolts, and temperature characteristics. So this particular sensor It goes from -10 to +125 degrees Celsius. And the absolute maximums. So again, the limits to protect the component. So it's importantly supply voltage. In this case, the maximum is 6, but if you pop back to the previous slide, it won't actually give you proper readings at 6, or won't. Yeah, it's anywhere from the range specified in the operating voltages. But yeah, don't connect a 9-volt battery straight to it, and we're not using a battery this week. We're going to power it from the microcontroller anyway. That'll let us program the micro as well. So again, from the data sheet MCP 9701 on page 10, you can see the typical circuit. This one is simpler than the one we had last week. The one last week, I believe, had a capacitor included. We don't need it for this one. So on the left-hand side of the typical circuit, you've got the MCP 9700. We have the 9701, but I guess the typical circuit applies for any of the temperature sensors on the data sheet. So you've got your VDD, or your supply voltage. It's connected to ground, and then the V out goes over to the right, so following that line along. And you see ANI, which is analog input, into a microcontroller, and then ground, and then it will output a voltage as well. So that will spit it out, but we need to program it to be able to read that and then to be able to print it so that we can see what it's measuring. So here, hop on over to Tinkercad. If you've used it before, great. If you haven't, it's in the links for this week. I'm not sure if you have to sign up or if you can just do it as a guest, but it's with Autodesk. So if you have an Autodesk account, I believe it will log into this. So get started. And you can see you've got on the right, you can search different components. So I've started with an Arduino and a breadboard. You can copy the circuit that I've sent you in this link, because the Arduino's micro isn't something you can typically get, but we've popped the breadboard in. Now we're going to search up, go back to the search for a temperature sensor. And that's just a generic one. So click on that, drag it over, just pop it there for now. We can name it. You can name your components if you want. So just type in temperature sensor. And then we are going to wire it up. So we see we have power, voltage out, and ground. And we're going to start with the jumper cable connection, which is that one. So you click and then drag down. We'll just zoom in there. You want to connect that to AO, which is going to be our analog input pin on the micro, and that's the one we need to reference in the code. You can move it around and straighten it up. And we will then make another one. So click to power. So we're going to connect it to the power rails in this case. If you remember, on the power rails on positive, just move that out of the way a little bit so that it is nice and straight, because I like it to be tidy. We're going to make it red for power. It's nice to color code things. It makes it a lot easier to keep track. And we're going to connect the ground pin to the ground, or the negative power rail. Okay, so those aren't electric. If you have a look, we'll just straighten those up, get them all nice. And we'll zoom in. So we have our 5 volts. That's the 5-volt power supply from the micro. And remember, that's within our operating voltage for the sensor. So we're going to connect that to the power rail. So that needs to be the positive. So it's the red. See, those are all connected. So if we move down, that red lead off the temperature sensor is connected to that one on the power rail, and then we connect that to 5 volt, and then we're going to connect the ground from the temperature sensor. So come down, come across, and then we're going to zoom in, find the ground pin on this side of our Arduino, and we're going to connect that like that. So it's nice and simple. That's your whole setup. Oh, and we'll just change it. Make sure we get the right colors, change that back to red. There you go. So that's a nice tidy circuit, and then you see there, you're going to power your Arduino by plugging it into the USB at the end of the Arduino, and then plugging that into an available USB port on your computer. So yeah, nice and simple. Go to the next one. We're going to program the microcontroller. So you see here on the left, we've got the Arduino IDE program with a new sketch. And on the right, you've got some other information from the sensor's data sheet, which is sensor transfer function. If you want to go into looking at Rocky's video that's in the links from activity 4, making measurements from the Bintroduction to Electronics boxes, it talks about the equation to figure out the voltage to the temperature. We don't need to do that today. We'll try and do that next week. It's a little more involved, but that's important because you'll get a reading from your sensor, and you want to be able to interpret that data, because it's not going to spit out temperature in degrees Celsius. It's going to give us a reading between 0 and 1023. That's the resolution of the pin. So you'll need that. And then down underneath on page 4, it's a screen grab of the temperature coefficient, which is something you need to know if you want to do that equation, but more on that later. So let's get started on the coding. So you've got a new sketch. If you don't have a blank sketch, you can go up to File and say New Sketch, but then this is what you'll start with. So for starters, we will initialize our pin variable. Oh, and it's also good practice to put comments into your code so you know what you've done. So if you put 2 forward slashes and then you type, that won't form part of your code. You can just make little notes to yourself or comments about what the different parts of your code do. And that's really helpful if you are working with other people, or if you're just coming back to it after ages and you won't have remembered exactly what everything means. So it's a really good way of doing it. So we'll just put in pin variable declaration, and then we're going to type int sensor pin equals AO semicolon, and then I'll comment that is going to be the input pin for our micro that we connect the voltage out, or the middle pin of the temperature sensor to, from the circuit we just drew up in the previous slide. So going down to your void setup, you're going to do another variable initialization here. So you are going to say pin mode, so sensor pin, so you got to say what kind of pin it is, input or output, so it's an input pin. So type that just as you see it. And we are going to set up the serial print function. That's where is going to be used to print out or to display within Arduino IDE what your temperature sensor is reading. So serial.begin, and then bracket 9600 close bracket semicolon. So that's the baud rate, which can vary, but for this one, don't worry about understanding it. Just type in what you see there, and you can explore it more later on. So again, just adding some comments so that we know what we're doing. And I mean, you don't have to be this explicit. You just, whatever you think is going to be useful to you going forward. So then we hop down to void loop. So a couple more lines there, and this is the code that's the main code that will run continuously. So now we're going to declare our variable for temperature. So that's the reading. So with int space temperature, very creative name, equals analog read. So it's going to analog read the sensor pin. And remember, we specified sensor pin as AO, so the microcontroller is going to know which pin to listen on. And semicolon at the end always with these lines of code. It will tell you when you try to compile if it's expecting a semicolon and you've forgotten one, so it's pretty helpful. And the next thing we need to do is to serial print. So that means it's going to write to the serial monitor, which I'll show you in a minute. And then the open quotes, the value of the temperature sensor is, and then a space, and then end quotes, and colon, parentheses, and semicolon, and then serial print line. So we want it on a new line each time, otherwise it just comes out as a big string and it's difficult to read. And we've just put in the name of our variable's temperature. So temperature will be the value of what the sensor is reading. So that's it. Actually, we're going to delay 100 milliseconds, so it does, wait a little bit before running the code again. And that just means it's not spitting out values at 1,000,000 miles an hour. So there's all the code there. So you want to plug in. Now you're ready to, you can save it as well, save this in case it crashes, and plug in your Arduino Micro. Make sure it's showing up on the correct port, because that sometimes changes. And then we're going to upload the code to the microcontroller. So it's thinking, it's compiling. Sometimes you get these error messages or just warning messages. They're not always errors. If you do get an error and you're stuck, you can Google it and try and troubleshoot it, or give us an email. But that's all there. So that's done. And I'm going to open the serial monitor. And if that's all connected up properly, you should be getting a value there. And I'm going to put my hand on it, and my hand is cold, so that's not working. Let's try something colder. I've grabbed a drink bottle I've got that's got some ice in it, and you can see those values are going to start to drop. We just give it a second. And you can try grabbing different things that are warmer or colder and see if you can get that temperature sensor to vary. So see it's dropping there as it's on the cold thing. So that's it for that, and then you can unplug it. That's it for this week. If you do want to try an extension to convert those values that you see, because the ones that were being spit out aren't degrees Celsius, that's just the value that the sensor is outputting. You can have a try if you go back and watch Rocky's video from the Introduction to Electronics making measurements. You can sort of start to work out how you can solve for temperature using that original value, but it's a tricky one. So for 1 hour, you may not have time today. We can work on that next week. And then next week, we're actually going to get started with the STM32 microcontrollers. So we're not going to totally do a deep dive into it. We're just going to have a close-up look at the chips on the Arduino micros that you're using now and compare those to the ones you'll be programming next year. Not a deep dive, but you can see how that's going to sort of transfer over. We'll also look more in depth into the pins available on your Arduino microcontrollers and what their functions are. And again, please send through your progress or questions to the BinarX at curtin.edu.au so we can support you. And with this exercise that we've just gone through today may not apply exactly to the sensors that you're using. Depending on what type of sensor it is, you'll need different parts of the data sheet. You might have to process the data differently, but don't worry. If you sort of start looking at things and figuring out what it is you might need or what you think is applicable, if you send that through to us, then we can support you and help you along that path of discovery to actually start taking readings from whatever sensor it is that you're going to be using, whether it's a thermopile or a photodiode or a temperature sensor or a pressure sensor, accelerometer. Obviously cameras and reaction wheel stuff would be a little bit different, but just getting started and building the knowledge along this path. So thank you so much for listening, and I hope you guys all have a great week.